So this one, I think it's question 2 or 3. When they ask, so a lot of these questions, guys, are multi-part. As we go through just questions throughout the year, I'll cut out the substance, and then we will talk by. I'm not going to cut the whole question out and go step by step and put in everything in the box. Does that make sense? But you'll get everything that you need from the discussion. I will also, at times, go further than what the question is asking, because this question, I think, cuts us off at just asking you what does the quadratic look like when you're done, once you substitute W in, okay? So we'll go a little bit further than that in this one as well. But this is a situation where we can use U substitution, or they're using W, so W substitution. And what you're going to try to do is try to recognize this is kind of a different format than what we've been seeing, but it is. Would you agree that it is still quadratic in form? That's a first power. That's a second power, right? Okay. And then they have something in common out here in front. Okay. It is very difficult. You could do it, but it's very difficult not to rewrite the x plus 1 and leave it as it is in the factor. Okay. What you would end up with is something like this. I would have, let's see. Like, think about this. This would be x plus 1, and this would be x plus 1. Okay, so that if I FOIL, I have x plus 1 times x plus 1. Will that give me x plus 1 squared? That makes sense? Now I have to go two numbers that multiply together give me 54, and add to give me 15, negative 15. Are there any that do that? I don't know that there are. Let's see here real quick. 9 and 6. Yeah, good. Negative 9, negative 6. Okay. So that would be the way of doing this without using U substitution. Do you think that looks kind of messy? Okay. But what I could do is I could say, okay, well, x plus 1 minus 9, that's a factor, should equal 0. X plus 1 minus 6 can equal 0. And you can go that route. You can get your answers. Okay. But what this U substitution or W substitution that they're using allows for is us to say, okay, well, just be careful on your homework. It's a capital W when you type stuff in. If you use lowercase, it's going to count it wrong. Let it be x plus 1. And then W squared would be x plus 1 squared, right? Can I now rewrite this as W squared minus 15W plus 54 equals 0? That make sense? Does that allow me to go W minus 9 and W minus 6 a little bit easier? It's just cleaner looking, right? I don't have that x plus 1 making things murky, clouding things up. So now we'll go W minus 9 equals 0, W minus 6 equals 0. And I don't think they ask you to do this in this question, but we can. W is 9, W is 6, and then we go back with, well, x plus 1 was actually W. Let's put that in. And now you can solve for x as 8 and 5. That kind of makes sense? Okay. So times that you can see the use or the benefit of this type of substitution is when you have something in quadratic form, like, let's say, question, let's do one. Like question 3. Okay, this is so the question we just did was a traditional quadratic. Okay, it just had maybe some different looking coefficients than we normally see, right? Okay, or I guess not coefficient, different variable terms than we normally see. We just see usually x squared or x the first. It was x plus 1. It was a quantity squared. Okay. But this is still quadratic. You could expand this. You could actually go x plus 1 squared, right? That is x squared plus 2x plus 1 minus 15x minus 15 plus 54 equals 0. Combine like terms and all that kind of stuff and still get down to the same answers. Say it again. Yes. In this situation, you don't need to because we didn't square anything. So if I put in 8, I get what, 81. This is going to be 9 times 15. So what's that? 9, 150, 135. So 81 minus 135 plus 54 will give me 0. And then try to say anything with 5, so it's 36. 15 times 6 is 90. So 36 minus 90 is negative 54 plus 54 is equal to 0. The only time you need to check right now, the only time you really need to check to make sure that there's extraneous solutions is if you introduce a squaring process. But this was quadratic, okay? It's quadratic in form, but like I said, it has kind of unusual variable terms. This example doesn't have unusual variable terms, but it's not quadratic, right? If I graph that's not going to give me a parabola, but it's quadratic in form. And the way I know it's quadratic in form is I look at those two exponents, and they are in a 1-to-2 relationship. Does that make sense? Much like the other one was, they're still in a 1-to-2 relationship with the exponents, these yellow exponents. Okay. And people say, well, how do you know that? Well, as we go through this course, you're going to learn a hierarchy of factoring techniques. There's other ways of factoring x to the 6 plus 9x to the cube minus 6. Okay. But the other way of doing this takes much longer to work through. We have to find the factors of 6, the factors of the coefficient for x to 6. We need to divide them, and that gives us possible solutions. And then we have to do synthetic division with all those possible solutions, and it will hopefully break this thing down to like x to the 5th, x to the 4th, and we keep going until we get all of our solutions. It's a pain in the butt. It's called the rational root theorem. Okay, it works. It's kind of like the default for factoring, but it's a pain in the butt. So I don't want to do that. I know it's there. I don't want to do that. So I know that's a long process. So I think, okay, are there other tools at my disposal? And U substitution is one of my tools at my disposal. And I check to see, okay, if I know I can use that when it's a 2-to-1 relationship between the terms of essentially your B term and your A term, okay, of their exponents. So we have that. So we let U, or like I said, they use W, right? So W equals x cubed. That means W squared would be x cubed squared, right? Is x cubed squared x to 6? Because we have a power raised to a power, right? We multiply those, so x to 6. So does that allow me then, in my problem where I have an x to 6, to rewrite that as W squared? And where I have an x to the 3rd, rewrite that as just W? Does that make sense, everybody? Okay. And they, in this problem, they stop you there. Okay. That's all they ask you for is to write that W squared plus 9W minus 6 equals 0. I've seen a lot of people in the last class, they asked about this question because they were missing it, and the only reason they were missing it is because it says an equation. Rewrite the equation. They just wrote W squared plus 9W minus 6. That's just an expression. You got to have the equal sign to give you in 0. Okay. A handful of people also missed it because they were using lowercase w. Okay. I don't know. I know some people were typing it in like in factored form. This does not factor, but I think there was another one that they had that they were typing in factored form. I don't know if they'll accept that or not. Okay. I don't think they're asking you to go that far. Let's talk about this one though. So this one doesn't factor. Okay. Can you think of two numbers that multiply together give me negative 6 but have to give me 9? No. So what if it doesn't factor using those techniques? What can I use? Okay, so the quadratic formula says x is equal to the opposite of b plus or minus b squared minus 4ac all over 2a, right? Do I have an x in my problem? The way I've set this up, is there an x there? Okay, so I replace x in my formula with w. And that's very critical that we remember to do that, and you'll see why here in a moment. And like I said, they don't ask you to do this, but we should be able to. So opposite of b is 9, plus or minus then. B squared would be 81, minus 4, a is 1, c is negative 6, all over 2a. So it gives me negative 9 plus or minus, so add 24, right? So is that 105? All over 2. So that's what w is equal to. Is everybody okay with that? But what did we allow w to be? What was it really equal to? X cubed. So I'm going to back substitute and now make this x cubed. Okay, so how do I solve for x cubed then? Cube root. That'll leave me x. So if I cube root the left-hand side, then I need to cube root the right-hand side. Does that make sense? So that's what x is going to equal. It's ugly looking, right? Okay. If you wanted to, you could maybe rewrite things using rational exponents, that kind of thing, but that's the way we're going to write it, okay? We have what we call nested radicals, okay? So a radical inside a radical. Nothing we can do about that in this situation. If I want to check, so I would use Desmos here to check this. I think that's going to be the safest route. So let's see if, what do we have? X to the 6th minus 9x minus 6. There's 9x to the third. And was it minus or was it plus? Plus 9x to the third. Okay, and now I'm going to let x equal, okay. Now, this calculator doesn't have like I don't think I type in cube root or anything like that, but it does have this function if you want to use it, where it puts a 3, I can put a 3 out here as my index, excuse me. And then on the inside, what do we have? Negative 9 plus, now the square root of 105 all over 2. Okay. Now just think about this. What kind of number? That's not 0, but what does this really mean? Yeah, there's a decimal point and then 15 zeros and then that 8, right? Is that pretty close to 0? Okay, so that is a solution. Okay, and if I put then the minus here, again, same concept. Okay, and the purpose, the reason we're seeing that is Desmos is using that as my input. Now it's probably using more decimals, but because I raised it to the 6, that number becomes very, 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 very small. Or large. And there's just rounding error that occurs there. Does that make sense, everybody? Okay. That's why it's not giving me just the 0 here. There's some rounding error occurring with the calculator. If you didn't use that cube root feature, you could write it this way. Cube root is the same as the 1/3 power, right? So you could write it that way. Again, like I said, it's not asking you in this assignment to do that, but it's an extension that we will use at some point. Okay, we'll use this quite a bit when we get into trigonometry. Trig is going to do something like this, just to give you kind of a little foreshadowing here. Let's go like cosine of x squared minus, let's say, 5 times cosine of x, plus 6. Okay, we could so what I would do is I would say, nope, gonna do this. u is going to be cosine x. So then this becomes u squared minus 5u plus 6. And that would give you u minus 2 and u minus 3, right? So then we get u is equal to 2 and u is equal to 3. And now I can go back and say, oh, cosine of x is 2 and cosine of x is equal to 3. And what happens there is that there is actually no solutions because of those values that we'll learn at trig. But if I wanted to do this with, if I wanted to factor that thing there with the quadratic formula, I would say instead of x equaling the quadratic formula, it would be cosine of x equals then the quadratic formula. Does that make sense, everybody? So what we learn, obviously things are more impactful if you know that you're going to use them, or you probably view them like they hold more clout if you know that they're going to be something that's important later on, right? Okay. If I'm a basketball player, football player, something like that, and we start this play, we run this play in practice, or we learn this play in practice, and I know that this is going to be our bread and butter, this is going to be a play that we use almost all the time, then I'm going to buy in and I'm going to try to learn this the best I can, right? Okay. If it's going to be a play that maybe we run once every 3 weeks, maybe I don't buy in. Okay. But this is a procedure that is going to be pervasive through the rest of the course. So it's hopefully we buy in and we kind of learn that now, and make things easier later on for us. Any other questions? We're all right. Okay.